Good evening, friend. Today, let's see a problem which is problem number 28 in spiral diagonal sum in Project Euler. So, what does the problem tell? So, starting with number 1 and moving to the right in a clockwise direction, a 5 by 5 spiral is formed as follows. So, let's take a look at the picture below. So you are forming a 5 by 5 grid, okay, and within that 5 by 5 grid you are forming the numbers in a spiral fashion. So if you look at the grid, the number 1 is starting at the center of the 5 by 5 grid, from the center cell of the 5 by 5 grid, and the numbers are generated in the means of visiting the cells in the 5 by 5 grid in a clockwise direction. So you start from here and then 2, then clockwise, so 3, 4, 5, then take a turn 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like this you form a spiral. So when you start from the middle cell and then you travel in the clockwise direction and you go through the entire 5 by 5 grid, so this is actually the 5 by 5 spiral that is getting formed. And it said that it can be verified that the sum of the numbers on the diagonals is 101. Right? So what they are saying is you take the sum of the numbers, right? So 25, 9, 1, 5 and 17. So that yields 57, and then you take the left diagonal, right? So 21, 7, 1, 3 and 13, which is 45. So the total sum is 102, but you counter this 1 2 times, right? When you summed up this diagonal and you summed up this diagonal, the middle cell, the center of the cell of the 5 by 5 grid is counted twice, so just take one of the 1 out. So the final sum is 101. So the question they are asking is, what is the sum of the numbers on the diagonals in a 1001 by 1001 spiral formed in the same way? So same way means by traveling in the clockwise direction. So we will eventually end up writing a program to find out what would be the sum of the diagonals in a 1000 by 1 and a 1000 by 1 a spiral. But probably let's take a minute to pass on the problem and see how we can do this kind of a traversal in a clockwise direction, probably starting from the small case. So let's go to the place where we can draw this out, right? So I'm starting from a smallest case, right, which is probably a 3 by 3 grid, and the center of the 3 by 3 grid is this cell, which is 1 comma 1, right? So now let's say if I'm going to start from this cell, this value will be 1, and then here it will be 2. So let's just draw out our traversal, right? So I will start from here. So 1, go to the cell 2, then 3, 4, 5, 6, 7, 8, 9. So this is one of the traversal that you could do, right? So you are starting from this cell, right? So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the traversal you get in a 3 by 3 grid. And if we take what was given in the example, so here I have a 5 by 5 grid. So because the row indexing will start from 0, it ranges from 0 to 4 on the row axis and on the column axis also. And middle cell is this one, which is a 2 comma 2, right? So that's the middle of the cell. And you can repeat the same pattern, right? So like if I just repeat that here, so you start from the center of the cell, right? So from here you start and you take one step, then you have to go down, which is like the clockwise direction, right? And then go here, then take a direction up, then move, right? And then go down, right? Like this and this. So this is a way you can do a clockwise traversal, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think that's what we saw, right? That's what we see here. It's traveling in the clockwise direction. So now the difficulty while you are going to program this comes in where you are going to take a change of direction. So you start, so it's easy for you to find the center of the cell. That's not a problem. But once you start at the center of the cell, you have to go to the next cell here and then immediately take a down direction. and once you cross here, then you have to take an upward direction to form a spiral, right? So you see a change of direction here, right? So there is a change of direction from here to here, right? And there is a change of direction here, right? Like from here to here, right? And then you are going up, right? So there is a change of direction, and that's where the complexity of boundaries come in, right? Like where you are going to decide the change. So let us see if there is some other way which we can figure out by probably having some kind of a structured way to draw the spiral, right? So I think with a little bit of experimentation on a white paper, so you can realize that there is two ways to draw the spiral, right? So one of the ways is starting from the start point and then going till the end point. The other way is probably, why don't you just start from here? So will you be able to trace that spiral by starting from the end and then going back to the start? Right. So if I just say this, so you know, in a 5 by 5 spiral there are going to be like 25 cells, right? So there are going to be like 25 values filled in each of the cell, right? So you just have to, like, let's travel this thing in the backward direction, right? So this is where I'm going to end. So if I start from here, which is the center of the cell, my spiral will end up here. So why don't I start from the end is the clever thought that you could apply. So if you start from here, so what will happen? You start from here, you just go here, then you hit a wall, right? So after that you can't go, then you just start going downwards, right? So until you hit a wall probably, and here you hit the wall, right? So now go on, right? So actually you are traveling in an anti-clockwise direction now, but still tracing the spiral, right? So and then go up, right? And you can't go above because you visited that cell already. So take a left and then go here, and you can't go to the next cell because you have visited that already. So take a bottom, right? You're doing in the reverse direction, anti-clockwise, because you're starting from the end, and go here, right? And just go and then reach at the center. So probably if I do this, then I can reach, right? So this will be like my, I will start from here, but I will just I will give the value of the end cell here. So instead of, so this is the 1 means this will be the 25. So 25, 24, 23, 22, 21, then 20. 19, 18, 17, 16. So if you travel this, you will see this 25, 24, 23, 22, 21, 20, 19, 18, 17, 16. So the same spiral, I'm traveling from the end and I'm reversing my direction in the clockwise direction, spitting out the numbers in the reverse order, and then I end here and I end here into the spiral which ends at the center. So why do we think that this approach is a better approach, or a program friendly approach that will probably get us to the answer what we want? So the reason is quite obvious. You know where to take the turn because you hit a wall, right? So what you saw above, you have to know where to take a turn, which could vary by the rows. So here you should take a turn here, and probably here you should take a turn here, right? So the downward turn, right? Or here you take upward turn here, but here you take upward turn in this column, not in this column. So you can get that done. You just need a little bit complicated boundary conditions to check for the turns where you need to make. But the one that we see below, the opposite way of traversing, makes your traversal more easier, right? Because there is a wall here, right? So moment you hit a wall, you know that, okay, that's it. There is no way you can go further, and you just have to take it down, right? And here also, you know that, okay, you can't go any way above this, right? Because already the cell is visited, right? So the cell is visited, so you can't go above, and you can't like, there is a wall this side, and anyways you are not going to travel in clockwise direction. You have to take a left turn, which is anti-clockwise. So so you are guided by the walls of the spiral which you are forming, and that makes programming this model a little more easier than what we would do in that. So only thing is, I just need to know the rules, right? Like for example, if I say my current direction and my change direction, right? So if I'm, let's say, like my current direction is left side, right? Like I'm coming left, so I'm coming here, coming here, coming here, and I'm hitting the wall, means then which side I should change, right? So my change direction here will be to the down. And now let's say like I'm going down, down, down like this, right? So I'm going in the down. So then when I hit a wall, when my current direction is down, I should turn to the right. And when I'm coming in the right direction, when I hit the wall, like I'm coming right, 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 and I hit the wall, I should go up, right? And when I'm just going up, up, up like this, right? And when I hit the wall, or I can't go, so the wall could be either a physical wall, like you hit the boundary, or you have a wall that is generated because you already visited this particular cell, right? So then you have to take a left, right? So we have, like, if your current, so you have the direction changes noted down. So if you are going in the left and you hit a boundary wall, then you have to take a down change, and you're going down, take a right change, and if you're going right, take an upward change, and if you're going up, take a left. And this is the direction map that you can use, right? And the boundary walls could be either one of the corners hitting off the map, or it could be like you are hit by a boundary because of visited cell that was there previously. Because see, here you can't go to this cell because this cell is already visited, so probably you are in the right direction, so the change direction should be up, right? And that's how you reach here. And here you can't go up, or you can't go to this side, right? So you can't go up because it's already visited cell, so you just turn to the left, because you're currently in the upward direction. So this is the easy way by which you can get this thing programmed to fill this 5 by 5 spiral, or for that sake 10 by 10 spiral. So let's take a look at a program that we wrote for this purpose, and let's see that, right? So we have a program which is spiral paths, right? And I'm just starting it with the basic size, right? Which is 5, and we know how to find the center of the grid. It is nothing but because it's going to be like a square thing, 5 by 5 or 6 by 6, you just take the midpoint by n by 2, and you will get like integer division of 5 over 2 will give you 2, right? So 2 comma 2 will be your midpoint, right? So you can see this here. So 2 comma 2, if you look at the coordinates, 2 comma 2 will be your midpoint. And we create a spiral grid, right? So we create a spiral grid which is of size whatever was the input given. And now, so we just come to the main part of the program. So let's see, like we from where do we start? So I'm going to start from the end, right? So I'm going to start from the rightmost corner, and I know how to identify my rightmost corner. It is the 0th row and the last columns, right? So that intersection is my starting point. So I initialize my row and column pointer to this particular value 0 and n minus 1. And what should be the value that should go in here, right? So I know there will be like n cross n values, right? So there will be 25 values. So my starting value is 25. So because I'm not starting from 1, you remember, right? So we are starting from the end, which is why it's like n by n. And my current direction, I'm going to start from the left, right? So I'm going to start from here and travel to my left in anti-clockwise direction. So you start from the left direction and you just assign the value of the cell, right? So you start from like in this cell 0 comma n minus 1, let's put 25. That's what we are trying to do. So 0 comma 25, you give the value that you assign, and then you get into a loop. So what is the iteration doing here? So the iteration has to run. So you need to travel the cell how long? So you have to start from here and you won't stop until you reach this midpoint. So you have to trace the full spiral. So what is your stopping condition? Until you reach the midpoint, don't stop. So that's exactly what we are saying, until the row and column is not equal to the midpoint, right? So we negate that. So until I have not reached, I'm going to travel. And how am I going to travel? I'm going to have this map, right? So this is my map. And my map says if my current direction is left, right? So I have to go to the left. So how do I go to the left? There is no change in the row wise movement, but in the column wise, I have to move one before. I am here, so I'm just going to go one before. So that is why we do a column minus minus. And what should be the value in the cell? It should be this value minus 1. So that's why we do a m val of minus minus. So you have decided where you are going and you have decided what is the value that will go into the cell. So now just get it assigned. So spiral of like row is same, right? You're not changing the row. So for the 0th row and then the n minus second column, which is 0 comma 3, so you give the value 24, right? And then you choose what should be your next column, right? So if you are on the left, you are just going to move on the same row, but the producing column. So that's why my next column is the current column minus 1, right? So my next column should be this column, but you need to check whether your next column, right, whether the cell you are currently in, right, is it a corner, right? Because the cell that you could be in here could be a corner cell, right? That you are banging on the wall, right? You enter the number, but you can't go beyond this, or you can't go beyond down, right? So we have to check whether the current cell you are in, is it a corner cell, or you have to check whether the next cell that you are going to go above is not equal to 0. Okay, so why do we say not equal? So what is that we are doing here? So I came here, so we got here, right? So there is no wall here. If you ask while you are in the cell, while you are here in 1 comma 4, if you ask whether you are there in a corner cell, the answer is no, because you are not yet there in a corner cell. But so can you go up? The answer is no, you can't go up, right? Because 25 is filled already, right? So that's why we try to get the next cell in the same direction and see whether the value is not equal to 0. So why are we saying not equal to 0? Because in Java, when you initialize the array, right, when you create the array, all the integer array, all the values are set to 0. So if the value is non-zero, then I know that I have visited that cell already. I don't have to keep like a reference to say like whether I visited a cell or not. So you could have done that. You could have created a Boolean array with the size n by n and probably mark the Boolean array for every cell as visited as true or not, but that's not needed. I could take the benefit of the fact that in integer data type of Java, every value is initialized to be of 0, right? So if I visit a cell, I'm not going to leave that cell with empty like 0 value itself. The moment I visit a new cell, we are going to assign the value mval. So if I assign the value, then it cannot be 0. So we use that condition to decide whether I have previously visited that cell. So whether the current cell is a corner cell, or whether the next cell in the same direction currently you are in, is it already visited. So if it is not equal to 0, right? So if it is equal to 0 means you have not visited, just go above, right? So if it is not equal to 0 means there is some value already filled there. So then you have to probably change your direction. Either if it is a corner, you should change your direction, or if the next cell in the current direction is already visited means you should change your direction. And we have that small little table for changing the direction. So that's what we are programming in. So if you are on the left, then the direction to change is down. And repeat that block for every direction change, which is there in our small little table. And if you are going in the down direction, then just manipulate your row pointers, right? So if you are going to be in the down direction, you don't have to like change your column. You just going to go to the next row. So you are in 0 0, you go to like 1 0, you go to 2 0. So that's why we make the row increase but the value decrease, right? I mean, value has to decrease for everything. You assign the value and then you find out what is the next cell in the current direction and apply that check. So now you will understand what is this function doing, right? So it's a corner. So the corners are very easily identified. There are only 4 corners, right? So 0 0, 0 comma 4, 4 comma 0 and 4 comma 4. So these are all the 4 possible corners that you could have. And because you are starting off from this corner, so I'm just checking for like either you are hitting the left corner or the bottom left or the bottom right. So those are all the things. I'm just checking for either one of the corners. Are you hitting one of the corners in an OR condition, which will either return true or false. So I'm just using that inside my if blocks, right? So if you are moving in the down direction, and this is what we said, you increment the rows and you are staying in the same column dimension, and you decide whether the current cell is a corner cell or the next cell is already visited. And if either of this is true, then the direction that you should change while you are on the down is to the right. So just take a change direction to right. And if you are on the right, then you just move on the same row but different columns, 40 to 41, 41 to 42. So that's why we do a column plus plus and do the same check whether you are in the current corner or this, and either one of it max, our direction says if you're on the right, your change is on the upward direction. And do the same thing for up, and you go this and you decide whether you are in a corner cell or in the same direction the next cell is visited, and either ways you change the direction if either of this is true. And if you are in up, the direction changes to the left, and the loop is just going to continue, and the loop will continue until you have visited the midpoint. And when you visit the midpoint, this will become 1, and by the time you have filled all the values in the spiral grid, which will have the values, and we can run this and see, right? So let's run this. So if you see, I'm just starting from 0, 4, which is what we told here. So beginning row and column is 0, 4, and the midpoint is 2. And I'm not printing the other things, but you could see the tracing of the spiral. So I'm just printing the spiral after we have finished, right? I'm just printing it, the spiral grid. So you could see like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, I haven't formatted the movement. You can just append the spaces, convert it, do that thing, so that because this 1 to 9 is a single digit number, and this is like a double digit number, so that's the thing. But you know, like you can compare it with the problem, so it will match from everything. And let's see the sum also, right? So the sum of the left leading diagonal is 45, and the sum of the right leading diagonal is 57, right? Which is what we saw here. And then we have to discount that one, which is what we will do here. So once you form the cell, it is just a simple loop. So you do the left leading diagonal sum in this way, and then you can do the right leading diagonal sum in this way, and you get the sum of both the diagonals. And then you just take out the one, and this can be hard coded because the place where you are going to overlap both the diagonals is always the center of the cell, and the center of the cell will always be 1. So it's okay to hard code it as 1, and then you get this thing, right? And now that's it. So we can just run this program for 1001 by 1001, but before we do that, let's just comment off the portion where we print, because otherwise my output buffer area is going to be overfilled with a big display of 1001 by 1001 matrix. And then we go above, and we can change this guy to like 1001 and get this run, and it's going to spit out what is the sum of the diagonals. So done. So we are starting from 0 to 1000, and the midpoint is 500 by 500, and the left leading and right leading, and the sum is this big number. So thank you for watching this, and I will meet you in another video.